Dear learners, I welcome you all to this online teaching session. Today, we will discuss about calibration of high performance liquid chromatograph. What is calibration? It is demonstration that a particular instrument or device produces results within specified limit by comparison with those produced by reference or traceable standard over an appropriate range of measurements. In other term, calibration means comparison of unknown with reference or traceable standard. Before discussing about various parameters for HPLC calibration, let us know what are the parts of HPLC system. Any HPLC system consists of solvent reservoir for placing mobile phase, pump. The role of pump is to pass a mobile phase from reservoir towards the system. Then sample injector or sample introduction system for injection of sample. Then column. Column is a heart of any HPLC system where actual separation takes place. Then detector for detecting a response. Then there will be a waste. So whatever is coming out or eluting from the column, after it is reaching the detector, it will pass to the waste, and then last is data acquisition system. This is your computer. This table depicts various parts of HPLC system and parameters to be evaluated as a part of calibration. For pump, the parameter evaluated is flow rate accuracy. For injector, injector accuracy and injector linearity are evaluated. For detector, detector accuracy, detector linearity and wavelength accuracy are evaluated. For column O1, temperature accuracy is evaluated and overall system is evaluated by system precision. First parameter, that is flow rate accuracy. The requirements to evaluate flow rate accuracy are you require 10 ml measuring cylinder, calibrated stopwatch and HPLC grade water. The procedure involves, first you have to prime all the solvent lines with HPLC grade water, then set the flow rate of mobile phase, that is your water, at 0.5 ml per minute. Wait for 15 minutes to stabilize the system and to assure that the pressure of your system is stable. After that, you have to insert outlet tubing of your HPLC system into 10 ml measuring cylinder, and you have to simultaneously start the calibrated stopwatch. So you have to measure the time required to fill that 10 ml cylinder, measuring cylinder. Similarly, perform the experiment for flow rate 1 ml per minute and 2 ml per minute. The acceptance criteria for flow rate accuracy is that the time taken to collect the water should be within plus or minus 2% of actual value. Table 2 depicts acceptance criteria for the parameter flow rate accuracy. Here the flow rates are 0.5 ml per minute, 1 ml per minute, 2 ml per minute. The actual time required for 0.5 ml per minute is 20 minutes, for 1 ml 10 minutes and for 2 ml per minute 5 minutes. And these are the acceptance criteria expressed in minutes. Next is injection accuracy. To perform injection accuracy, you require HPLC wire, calibrated weighing balance, HPLC grade methanol and HPLC grade water. So first you have to prepare mobile phase. It is a mixture of water and methanol in the ratio of 70:30. You have to place the mobile phase in the reservoir. Set the flow rate of mobile phase at 0.5 ml per minute and set the runtime of your method 1 minute. If you have column oven with you or with your system, you have to set the temperature at 25 degree plus or minus 2 degree centigrade. Then you have to take HPLC vial and you have to fill that vial with HPLC grade water and you have to properly cap it. After that, you have to weigh that vial and you have to record the weight as W1 gram. Then place the vial into chromatographic system and you have to perform 6 injection of 50 microliter volume from that vial. Once all the 6 injections are over, you have to remove that vial from the system and you have to weigh it, and that weight will be W2 gram. Then you have to calculate mean injection volume per injection using this formula. So mean injection volume in microliter can be calculated as W1 minus W2, means initial weight and then final weight, upon 6 because we have performed 6 injection, into 1000 because that value will be in ml, so we have to convert it into microliter. So this is the 1000 and this is rho. Rho is the density of water. So you can convert weight into volume. What is the acceptance criteria? The mean injected volume should be 50 plus or minus 1 microliter. You can perform the same experiment using 20 microliter volume also. Next is injection linearity. To perform injection linearity, you require 100 ml volumetric flask, one. Then you require standard caffeine, calibrated weighing balance, HPLC vial, then sample filter, means to filter the solution, then HPLC grade methanol and HPLC grade water. To perform injection linearity, you require solution of caffeine, that is 100 ppm concentration caffeine solution. So for that, accurately weigh and transfer 10 mg of caffeine into 100 ml volumetric flask, dissolve with mobile phase, that is water methanol 70:30, and prepare 100 ppm solution. Now how will you perform injection linearity? So you have to inject first blank. So inject blank, then followed by different volumes of the 100 ppm solution. Of course, you have to filter the solution and you have to fill into the vial. You have to place into the HPLC system and you have to inject different volumes from the same vial. That is 10 microliter, 20 microliter, 30, 40 and 50. And you have to record the peak areas for these volumes. And you have to plot the graph of peak area versus volume injected. So what is the acceptance criteria? The graph obtained of area under curve versus volume injected should be linear and the R square value should not be less than 0.99. Next is for detector. First we will see PDA detector accuracy. For the same, you require 100 ml volumetric flask, caffeine, calibrated weighing balance, vial, filter for filtration of sample, and of course mobile phase, methanol and water HPLC grade. Again you have to prepare standard solution of 100 ppm. As we have discussed, you have to filter it, place it into vial, into system, and you have to start your system using mobile phase at given flow rate. So what you have to do? You have to select 3D mode and set the wavelength range as 200 to 400 nanometer and inject standard solution, that is 100 ppm of caffeine solution, 20 microliter, and record the chromatogram at the wavelength of 202 to 208 with an interval of 1 nanometer, and at 269 to 275 nanometer with an interval of 1 nanometer, and note down the maximum absorption, note down the absorption and absorbance and height. What is the acceptance criteria? The maximum absorbance should be at 205 plus or minus 2 nanometer and 272 plus or minus 2 nanometer. This is for caffeine. Next is detector linearity. To perform detector linearity, you require 100 ml volumetric flask, then 10 ml volumetric flask 5, caffeine, standard caffeine, calibrated weighing balance, then 5 HPLC vials, then sample filters 5. For each dilution we will be using, or you have to use different filter, then HPLC grade methanol and HPLC grade water. Again you have to prepare 100 ppm of standard caffeine solution using mobile phase as a diluent, and after from this 100 ppm solution of caffeine you have to prepare different solutions which are used for detector linearity. So you have to prepare 10 ppm solution, 20 ppm solution, 30 ppm, 40 ppm and 50 ppm solution from this 100 ppm standard caffeine solution. Procedure: first inject the blank followed by all the solutions which are prepared, that is 10, 20, 30, 40, 50 ppm. Record the peak area for all the solution and plot the graph of peak area versus concentration. For detector linearity, we will be plotting the graph of peak area versus concentration, while in injector linearity, the plot of peak area versus volume injected is plotted. So what is the acceptance criteria? The plot of area under curve versus concentration should be linear and R square should not be less than 0.99. Next is wavelength accuracy. The procedure is create an instrument method with a wavelength in nanometer. Means for your sample, here we will take caffeine only. So you have to create the method and you have to set appropriate wavelength. Inject the blank followed by standard preparation of any fixed volume of caffeine. Note down height or absorbance. The acceptance criteria, the lambda max should be the lambda max should be plus or minus 2 nanometer from the standard value of the standard value. Next is column oven temperature. For column oven temperature, you require calibrated thermometer. Column oven temperature accuracy is evaluated with calibrated thermometer, and you have to perform for 30 degree centigrade temperature and 60 degree centigrade temperature. So firstly place the thermometer probe in column oven and set the column oven temperature at 30 degree centigrade. Then wait till the temperature stabilizes. Then record the temperature displayed on thermometer. Means what you have to do? You have to set the temperature of column oven at 30 degree. You have to place the thermometer. The once that temperature is stabilized, you have to record the temperature on thermometer. Similarly, you can perform for 60 degree centigrade temperature. The acceptance criteria is that the resulting oven temperature from the thermometer display should be within plus or minus 2 degrees centigrade of the set temperature. Last is system precision. The requirement for system precision is that you require 100 ml volumetric flask, caffeine standard, calibrated weighing balance, HPLC vial, sample filter, and methanol, HPLC grade and water. Again, for system precision, you have to prepare 100 ppm of caffeine solution using mobile phase, you have to filter it, and you have to place it into the vial. The procedure is that inject blank means mobile phase you have to inject, followed by 6 injection of 100 ppm caffeine solution. For all the 6 injections, note down area and retention time. Calculate percentage RSD of retention time and peak area for all 6 injections. What is the acceptance criteria? The percentage RSD of retention time and peak area for all 6 injections should be less than 1%. This is the reference which I have used for preparation of this presentation. Thank you all for listening to me. Thank you.